Sorry, my camera cut out, so I'm back again. So basically what happened was, where were we? I've actually gone ahead. I didn't realise the camera had cut out, so I go back to where we were, which was 4000, and we tried to read in the ID check. We'd loaded the RAM, the first bank of RAM was 0, and what had happened, that's what we ended up with in the first video. Unfortunately my camera messed it all up, right? But as you can see, it came out a completely different CRC. It checked it, there was no match for board found, and it's given me the opportunity to type in whether I want to store that and give it some information. Now I don't want to do that because obviously it is faulty RAM, so if I enter it, it says not added. So if I go back to the beginning and I do a block read, I can demonstrate why it failed. This is what I was actually doing before I realised the camera had cut out, so sorry about that. As you can see, the data this time is not all zeros. As you can see, it's 1 zeros, most of them are zeros, but there's a load of nonsense in there. See, that seems to be okay, that bit there, and then up here, oof, that bit there is a complete load of rubbish, so it's not done anything with that. Goes up, more rubbish, exactly. So as you can see, it's just nonsense, and it started at the address 4000, which is the first bank of RAM on the Pac-Man board. I think if I'm looking at my data sheet, it says that's the character video RAM. So the character video RAM on this Pac-Man board is obviously got a bit of an issue. So it's either the RAM, it's either the socket, it's the ribbon cable linking the boards, or something like that. But there's obviously an issue somewhere there that's not allowing me to write that RAM fully. Now I can actually prove that this works by going back to 44, which is the second bank, and this is actually the character color RAM. So there you go. And if I do a block write to that, so I'm storing that amount of data into that address, starting from that address, and that's the data I'm putting in 0. It's loaded it all in. I'm going to go back and I'll do my CRC check again, or ID check, and as you can see, it's done it this time again. So there it's 2114 RAM filled with 00, so it's done it. We can change that to say an FF again. I'm just trying to prove that this is obviously doing this. I've set the address back to the beginning. We're going to do a block write, because if we don't do that, it will keep the 0 in it, obviously. It's loaded it, go back, do an ID check, and it will then come back and tell me, hopefully, it's got FF in it, which it has done. So the second bank of RAM on this Pac-Man board appears to be fine. Now all 3 banks of RAM are exactly the same. The hardware is exactly the same. The only difference is there's different select lines for the banks. So I will need to look at that first bank and see what's going on, but knowing what I've done to the board in the first place, there's probably no surprise I've probably damaged the RAM chips. But it looks to me like bank 2 seems to be absolutely fine. Now there is a third bank which we can check on 48. They go up every 400 hex, so we can set that and do a block read of that, and you'll see it's full of rubbish. Now I think bank 3 is pretty knackered as well, so that's obviously the RAM that's not initialized because it's been turned off, turned on, and it's full of random stuff. So if I do that and I do FF this time to write it, block write, we'll see what that one does. And I think this is even worse, to be honest. So it claims it's done it. The tester won't know if it's done it right or not, because obviously it's going to the RAM, but whether the RAM actually holds it is another matter. Go back to the beginning, do a block read, and as you can see, it looks almost the same. So bank 3 of RAM is not doing anything at all. Looking at it, it's staying as it is. So there's something wrong with that bank, there's something wrong with the first bank. But if I go to the second bank and do it, we'll go back and read it in just to show. As you can see, the second bank appears to be fine. It's doing what you expect. Now you can do anything, you can put anything in there. So for example, FF is what obviously I was using to test it, but if I wanted to put in, say, 56 for example, you can just do a block write, and it will then do that. Go back, read it in, you should see it's all full of 56, and there you go, it is. So by using the ID check, you can actually check 2114 RAMs or any other RAMs, to be honest, without removing them off the board. As long as you've got access to the RAM, i.e. the board will allow you to read and write to it, and also, you know, all the addresses are all fine. If you've got a board that obviously you can't read anything back or write anything to it, then you're not going to get anywhere. But as long as the board is semi-operational, lets you get access to that RAM and you can read and write to it, you're okay. So you can do that. Now the other thing can actually do is, if I go back to 4.4, you can actually just put a single number in. So if I wanted to just change 1 byte to 67, you can say write data, and what happens is it says data loaded 67. You can read it back, data read 67. If you want to go up one address, I've actually got these two buttons. The software that's currently in the testings doesn't have this, but the new ones will, and you can upgrade as well with the new software. So if I click that, it will go up one address, as you can see. If I read the data, it's 56, which is what you loaded in before. If I go back and click it again, it's 67, which is what I've just loaded in. So as you can see, that's a short video, well actually two because of my camera, showing you how you can read and write to video RAM, and it will work with other RAM as well. Video RAM obviously is just a little bit different, but it will allow you to read and write to the RAM, and by doing that you can actually test for different things. Now the way I actually set up those CRCs in the first place, I'll quickly show you. So if I go back to the beginning, because I know 4400 works, and what we'll do is we'll put in, let's put in, for example, say 04. Okay, so I'm going to write 04 into it. Okay, we'll go back, we'll read it in, just check it's all done it. When you do this, you want to just quickly check it to make sure it has actually done it right, because you don't want to store the wrong thing. As you can see, they're all 4s, which indicates 04 effectively. There's nothing spurious there, it looks all good. We'll set the address back, and then we'll do an ID check, and this will fail because it won't know that it's full of 4s. As you can see, it's checked, it says no match for board found. So on this occasion, we're going to type in 2114 RAM dash, and then filled with 04, and that's it, and then enter. It says CRC added. So now if we go back, and we've already filled it, do an ID check, what it'll do now is it will read all that data back in again. It won't store the data, it's read it all in, it's compared it, it's checked the CRC, and it says 2114 RAM filled with 04. So by doing that, you can actually create CRC checks for the RAM. So effectively you can check the RAM, so you can put different bit patterns in and you can make sure that it's all hunky-dory. So there you go, that's another video to put onto YouTube. Thanks a lot for watching, and I'll follow up with another video soon on something else. Thank you, bye.